In this video, I'm going to talk a little bit about multiple allele traits, and then I'm going to do a multiple allele question. So multiple allele, what we are going to focus on for traits is going to be blood type. Blood type is the ultimate example of a multiple allele trait. This table here shows you the possible genotypes for the 4 blood types. Remember, multiple allele has more than 2 alleles that are used to code for that trait. For blood type, we have 3 alleles. We have A, we have B, and we have O. So that makes blood type a multiple allele trait. If we would have only had 3 blood types like A, B, and AB, without this O, we would have just a regular monohybrid cross, which would actually classify as a codominant cross. But because we have the O, that means that there's 3 alleles, which means it has to be a multiple allele trait. Now the possible blood types we know are A, B, AB, and O. To have blood type A, there are 2 possible genotypes that our DNA can have. We can either be homozygous, which means that it's A and A, or we can be heterozygous for type A blood, which is AO. Same with type B blood. We can either be homozygous, which is big B, or we can be heterozygous, which is BO. In order to have blood type AB, we have to inherit the allele A and the allele B, and those are going to represent codominance. So these are going to be codominant alleles so that you have AB blood, not just A and not just B, both together. And then in order to have O, you have to have OO in your DNA. Okay, and if you notice that when we have AO or BO, the O is masked, and the only way to have O-type blood is to have 2 O's, which shows you that O is the recessive of the 3 alleles. So A and B are going to be codominant. Anytime that they are inherited together, you have both in your blood type. And then type O is going to be recessive, and the only way to get type O is to have both O alleles. So in a multiple allele problem, you're going to actually skip step 1, which is to pick letters and define them, because we know what they are: type A, type B, type O, and type AB. Like, we can't define those. So you're going to actually only do a 3-step method for this, skipping step 1 of the 4-step method. Okay, so the problem here says a woman with type AB blood and a man heterozygous for type B blood have a child. We want to know the possible genotypes and their percentages that the baby could have. So when we skip step 1, we can go right in and show the cross. So we know that the woman has type AB blood. So that means that her genotype has to be AB. The man, on the other hand, is heterozygous for type B blood, which means that he has to be BO. If he would have been homozygous for type B blood, he would have been BB. But because he's heterozygous, hetero means different, he's going to be BO. So that's the first step, is we show the cross. It's going to be pretty self-explanatory for multiple allele questions, because if the woman is type AB, you know that hers is AB. If she would have had type O, it'd be OO. The only thing you have to look out for is if they're type A or B, whether they're homozygous or heterozygous. And again, if they're heterozygous, it's whatever type they are. So in this case, it's type B, it'd be BO. If they're heterozygous for type A, it would be AO. And if they're homozygous, it's either BB or AA. So then we go through step 3, which is doing the Punnett square. So again, we are going to take these alleles and we're going to break them up. So for the female, half of her eggs have the allele for type A blood, and half of her eggs are going to have the allele for type B blood. And that's what we're showing here. We take the man's alleles and we break them up so that half of his sperm have the allele for type B blood and half of them have the allele for type O blood. Then we go through the Punnett square and we bring the A down and the B across. So we have one type AB blood here. We do the same here, B down, B across. So this is homozygous for type B blood. We bring the O down and the A down and the O across. this would be heterozygous for type A blood. And then here we bring the B down and the O across, and this is heterozygous for type B blood. So the next step is to represent the phenotypes. Okay, we aren't looking at the genotypes for multiple allele. I just want to know the chances of having each type of blood. So when we look at this, we notice that one of the 4 codes for type AB blood. So that means that 25% is AB. This one right here is type A blood, so we know that 1 out of 4 is type A, so that'd be 25% type A. And these 2 here show type B blood. So 2 of the 4 is type B, and that other 25% would be type A. So this is where the 1 out of 4, 25% type A, 2 out of the 4 is 50% type B, and 1 out of the 4 is 25% type A. And that's all you have to do for a multiple allele problem. This is probably the shortest of them all because you don't have to pick a letter and define them. They're already defined for us. So you can skip step 1. And for step 4, you only have to tell me the phenotypes, so the different types of blood and the chances of the baby having that type of blood. So in this case, the baby has a 25% chance of coming out with type A blood or AB blood, a 50% chance of coming out with type B blood, and a 25% chance of coming out with type A blood. And that's a multiple allele problem.